All right. So, counting, new topic. Let's say Bob, Joe, and Mo are running a race. How many different outcomes are there for the race, assuming nobody ties? Well, to figure this out, we can make a tree diagram. So, all right. So, Bob could finish first, or Joe could finish or Joe could finish first, or Mo could finish first. Now, for second place, well, if Bob finishes first, well, Joe could finish second. If Bob finishes first, well, Mo could finish second. Now, if Joe finishes first, well, then Bob could finish second. Or if Joe finishes first, Mo could finish second. Now, if Mo finishes first, well, then Bob could get second. Or if Mo finishes first, Joe could get second. Now, what about third? Well, if Bob finishes first, Joe finishes second, then it must be that Mo finishes third. If Bob finishes first, then Mo finishes second. It must be that Joe finishes third. If Joe finishes first, Bob finishes second. It must be Mo finishes third. Joe first, Mo second. You gotta have Bob third. Mo first, Bob second. Joe's gotta be third. You have Mo first, Joe second. Bob's gotta be third. Aha! We see that there are 6 different outcomes for the race. These are it. Well, let's think about how we could get this answer a little faster away. So, you got 3 branches, each of which has 2 branches, each of which, well, only has 1 branch. So, there are 3 branches, followed by 2 branches, followed by 1 branch. So 3 times 2 times 1 counts the number of branches. So, new problem. Bob, Joe, Mo, and Sam are running a race. How many different outcomes are there for the race, assuming nobody ties? Now, you could do this problem with a tree diagram, but it's going to be a huge pain. You're going to have 1, 2, 3, 4 branches. Now, off each of those branches, you're going to have 1, 2, 3 branches. 1, 2, 3, 1, 2, 3, 1, 2, 3. And then off each of those, you're going to have 2 branches. 1, 2, 1, 2, 1, 2, 1, 2. So it's a huge pain. So you got 2 branches. And then off each of those, you're going to have 1 branch. So I'm just going to do a terrible job drawing my tree diagram, because I don't want to draw the whole tree diagram. That's a huge pain. All I want to figure out is, well, how many branches are there going to be? I'm going to have 4 branches, followed by 3 branches. So I have 4 branches, each of which has 3 branches, each of which has 2 branches, each of which has 1 branch. So I see, okay, well, there's going to be 4 times 3 times 2 times 1 branches, which is going to give me 24 branches. 4 times 3 times 2 times 1. That'll give me the number of branches. 4 branches, each of which has 3, each of which has 2, each of which has 1. Or another way to think about this is there are 4 chances for first, or 4 possibilities for first. Now, once first place has been assigned, there are 3 possibilities for third. Second. And now, once first and second are assigned, there are 2 possibilities or choices for third. And then, all right, once the first 3 places are assigned, well, there's only one person left. So there's one possibility left for 4th place. So 4 choices for first place. Once you've made your selection, there are 3 possibilities left for 2nd place. Once you've made that selection, there are 2 possibilities left for 3rd place. Once you've made that selection, well, the last place is determined. There's only 1 possibility left for last place. So 4 times 3 times 2 times 1 gives you the number of branches, 24. So 24 outcomes are possible. Now, let's say 10 people are running a race. I want to know, how many different outcomes are there for the race, assuming that nobody ties? So again, you could do a tree diagram. Now it's going to be a nightmare if you were to do that, but you really only care about the number of branches the tree diagram has. So that's really what we want to know. You're going to have 10 branches to start with, each of which is going to have 9 branches, each of which is going to have 8, each of which is 7, 6, 5, 4, 3, 2, 1, etc. That's how many branches your tree diagram is going to have. If you type that into your calculator, that gives you 3,628,800. That's the number of branches. Now this was a huge pain, doing 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's just a pain writing that out. So a lazy way of writing that out is writing 10 with an exclamation point after it. It stands for factorial. So that's called 10 factorial. So 10 factorial, 10 with exclamation point, is just a lazy way of writing down this. And your calculator can do that. So if you type 10, and then if you hit math, go over to PRB for probability, go down to option 4, you do C factorial. 10 factorial, there we go. Now you hit enter, there's the answer. Okay, so in general, a collection of n items can be arranged in n factorial different ways. And n factorial, that means take n, multiply by n minus 1, n minus 2, n minus 3, all the way until you get to 1. So like if n is 10, you're going to do 10 times 10 minus 1 times 10 minus 2 times 10 minus 3 times 10 minus 4, all the way to 1. So that's how you do factorial.